Let's rewind the clock back to 2008. The world of high-performance databases, well, it was hitting a wall, a really big wall. A problem so fundamental it was choking the entire industry. What happened next wasn't just another solution. It was the birth of an entirely new kind of machine. And its origin story, you'll see, is packed with surprises.
So to really get to the heart of this story, we have to start with a fact that, honestly, sounds completely backwards. In 2008, Oracle launched its very first engineered system, a machine that was supposed to be the future, their grand vision. But here's the twist. It didn't run on Oracle hardware. Nope, it ran on servers from a huge competitor, HP. Understanding why, well, that's the key to this entire story.
But before we get to the solution, you really have to understand the massive problem everyone was facing. I mean, data was just exploding, right? But the way we processed it was stuck in the past. And this created this colossal traffic jam between where all the data lived and where it actually needed to be analyzed.
I mean, just look at how simply this breaks down the problem. On one side, you've got your storage acting like a fire hose, just blasting every single bit of data it has across the network. Then, on the other side, the database server CPU is just drowning, totally wasting precious cycles sifting through this mountain of information just to find the few rows it actually needs. It was a brute force approach, and it created this monster I/O bottleneck that was just killing performance.
So what did Oracle do? In 2008, they roll out their answer, the Exadata V1. And yeah, it came with that completely unexpected partner, HP. Now, this wasn't just some weird business deal. It was a strategic masterstroke, and it was designed to prove a much, much deeper point.
Okay, so this is the crucial part. By running on a competitor's hardware, Oracle was making a really bold statement. They were basically proving that the innovation wasn't about the physical box. It wasn't about the brand name on the server rack. The real breakthrough, the secret sauce, was in the fundamental design, the architecture of how software and hardware could finally work together in harmony. At the heart of this brand new architecture was this groundbreaking idea that just completely flipped that old, inefficient model on its head. You know, instead of moving these massive amounts of data to the intelligence, they asked, why not move the intelligence directly to the data? And that idea was brought to life with a technology they called SmartScan. For the very first time, this let the database push parts of a SQL query, the actual database logic, down into what they called storage cells. Think of these as intelligent controllers sitting right on the disk drives. All of a sudden, the storage layer wasn't dumb anymore. It became an active player in the query itself.
So here's how it worked. It was actually pretty elegant. The query goes straight to the storage cells. Those cells do all the heavy lifting right there, filtering out all the junk, all the unnecessary rows and columns, right on the disk. And then, finally, only that tiny, relevant sliver of data gets sent back across the network. The bottleneck? It was totally broken.
But you see, this wasn't just about making one thing faster. This was about proving a radical new philosophy for how you design high-performance systems. Exadata V1 was the test case. It was the proof of concept for a whole new category of machine, the engineered system. And when Larry Ellison says something like this, he's not just talking about speed. He was signaling a fundamental shift in strategy. The old rule was, you buy your hardware from one company, your database from another, and hope for the best. Oracle was basically declaring that that whole siloed approach was over. And the impact was immediate. It was crystal clear. Exadata V1, even running on HP servers, proved that databases run dramatically. I mean, almost unbelievably faster when the hardware and the software are designed to work together as a single cohesive unit. The concept was officially proven. It was a home run. So with this concept now validated out in the real world, V1 became the critical first step in a much larger, much more ambitious plan. It basically set the stage for Oracle to move toward controlling the entire technology stack, from the application all the way down to the silicon.
So Exadata V1 was this wildly successful proof of concept that really started a revolution in database architecture. And in doing so, it left the entire industry with one really obvious and very critical question about what was coming next. If the architectural magic was this powerful, what would happen when Oracle finally controlled the metal too?